Hello, and today's learning target is all about the Pythagorean theorem. So the learning target today is just being able to use the Pythagorean theorem and its converse. So we're going to also use that converse to be able to classify the type of triangle it is. So let's begin with what a right triangle is, because in order to use the Pythagorean theorem we have to know that it is a right triangle. So a right triangle contains one right angle, and the sides that make up the angle are called the legs. And the side opposite of the right angle is known as the hypotenuse. So on a right triangle, we always have the legs that are making up that right angle, and the hypotenuse is always that longest side that's across from the right angle. The Pythagorean theorem only works in right triangles. So in a right triangle, the square of the hypotenuse is equal to the sum of the squares, also known as a squared plus b squared equals c squared. So our c is always the hypotenuse, and a and b are our legs. It doesn't matter which one is which, because when we plug this into our formula, we have addition, and order doesn't matter. So if I want to use the Pythagorean theorem to find a missing side length, the first thing I want to do is identify which side length is, or which side is the hypotenuse. So in our first example, in example 1a here, our x is the hypotenuse, and then so therefore that's going to be our c. And once we figure out what our c is, it doesn't matter which one is our a and which one is our b. We could call 2 our a and 6 our b, or you could do 6 as your a and 2 as your b. So once we plug this into our formula, we're going to have 2 squared plus 6 squared equals x squared. So we're going to go ahead and solve for x, but they want us to do it in simplified radical form. The other day, we were working on practicing simplifying radicals, so this will be an opportunity to just get a little extra practice. So I'm going to go ahead and do some order of operations to just simplify this expression. So 2 squared is 4, 6 squared is 36, and x squared we're just going to leave as x squared because we're not sure what x is yet. Next, we'll combine that the like terms on that side. 4 plus 36 is 40 equals x squared. And then we'll get rid of that squared by doing a square root. So x equals the square root of 40. So essentially we have solved for x, but they asked us for in simplest radical form, or simplified radical form. Technically, you could plug this into a calculator and you get about 6.3, but since they're asking for simplified radical form, we're going to try to figure out if there's a biggest perfect square that fits into 40, which we could break up 40 to be 4 times 10, or the square root of 4 times the square root of 10. Since the square root of 4 is a nice whole number, we can take the square root of that, and our ending answer would be 2 times the square root of 10. Taking a look at our next example, take an opportunity to just label your A, B, and C before, specifically pick your C before I go ahead and start on this problem. So I'll give you a second to decide which one is going to be our C. If you chose 20 as your C, you are correct because it's across from our right angle. It's also that longest side, that which means it's the hypotenuse. So it doesn't matter which one is our A and our B for as far as the x and the 14. So because again, order doesn't matter with those. So when I plug those into our Pythagorean theorem, we're going to have x squared plus 14 squared equals 20 squared. We can go ahead and simplify these expressions. We don't know what x is, so we'll just leave it as x squared. 14 squared is 196. feel free to borrow a calculator if you don't have that one memorized. 20 squared, 20 times 20 is 400. Now we want to try to get x by itself, so let's move that 196 over to the other side. Be left with x squared on one side, on the other side we'll be left with 204. In order to get rid of that square, we'll square root both sides, so we're left with x equals the square root of 204. Now again, we've solved for x successfully, but they're asking for that simplified radical form, so we're going to just do our best to try to simplify it. So when you do get this answer, please circle that answer, but then also try, as we practice simplifying radicals, also circle that second answer as well. You could maybe put a square around one and circle around the other. Since I know that 4 is the biggest perfect square, so if you try we had those lists of perfect squares on our notes from the other day. If you want to just try dividing a couple of them just to see what works. When I divide this by 4, I get x equals square root of, because 4 fits into it 51 times. So then we're going to be left with the square root of 4 is 2 times the square root of 51. If you were to just have typed this into a calculator, you would have got about 14.3. But since we're practicing simplifying those radicals, we're going to just go with that for our answer. So taking a look at our next one, this one we have 2 x's. But we're still going to solve it the same way. We're going to use this Pythagorean theorem. We're going to just figure out what our c is, plug up, and then decide which one's a, which one's b, plug them all in, and then we're going to go ahead and just use our knowledge of algebra to solve. So first thing I notice is that the across from the right angle is this x, so that's going to be my c, and then I'll just decide which one's my a, which one's my b. Doesn't really matter because again, order doesn't matter with the a and the b. So when I write out when I plug these all into my Pythagorean theorem, my a is 4, so I have 4 squared plus, we have the expression x minus 2 is my b, so x minus 2 quantity squared equals x squared, which was my c. So when I simplify this for my next step, so before we've just been getting numbers when we simplify those expressions. In this case, we're actually going to FOIL this x minus 2, because when we have an x minus 2 quantity squared, we can't distribute that because of that minus sign. The definition of squaring something means we're going to multiply it by itself. So if you just write the expression out twice next to each other, we can simplify 4 squared. We know 4 times 4 is 16. X squared, we can't really do anything with that yet. So I'm going to go ahead and FOIL this this expression in the middle here. So x times x will give us x squared. X times minus 2 would give us minus 2x. Minus 2 times x would give us negative 2x. And negative 2 times negative 2 would give us negative 4. So just because we FOIL doesn't mean that the rest of the equation goes away. So notice that I brought the 16 and the x squared along for the ride. So I noticed that there's some like terms that I can combine. So the 16 and this minus 4 would combine to give us, oh, I'm sorry, that was a minus times a minus, that should be a plus 4, I'm sorry. So whenever we have a negative times a negative, it's a positive. When I combine 16 and 4, we would get 20. When I combine these negative 2 x's, we get negative 4x, and we have this x squared. This other x squared is still hanging out over here. So I'm also going to combine that x squared with the other side. So since it's positive, I'm going to subtract it. So when I subtract x squareds, hey, look at that, they go away. We'll be left with negative 4x plus 20 equals, so since I subtracted x squared from x squared, there's nothing over there. The number for nothing is 0. So then now I'm going to get all my whole numbers on the same side, or numbers without the x's, so all my constants. These will cancel. We'll have negative 4 equals negative 20. We'll divide both sides by negative 4. Negative divided by a negative is going to leave us with a positive answer. And our x is negative 20 divided by negative 4 is 5. All right. So if that one seemed like a lot of work, it's because of all this algebraic expression right here. I promise that there won't be as many. We're going to have more like our first two examples, but on the homework, if you notice that I'll have like an example, see example 1 for the problem. So if you have questions on the homework, just take a look at these 3 examples for the examples that on the first couple of homework problems. So a Pythagorean triple is just it's just a set of 3 numbers basically that works into this Pythagorean theorem. Whenever you have 3 whole numbers that work out in this Pythagorean theorem, we just call it a Pythagorean triple. So here's a couple of Pythagorean triples. Technically there's an infinite amount of them. Basically it can be also any multiple of these. For example, so right triangles, we already know about similarity. So if I have a 3, 4, 5 triangle, if I like doubled, so if I had the same ratio for all 3 sides, for example 6, 8, 10 would be a multiple of this 3, 4, 5 triangle. So if I could triple it, that would give us like 9, 12, 15. So any multiple of those will also be considered a Pythagorean triple. So any whole number, these are just examples of whole number combinations that work out in that Pythagorean theorem. Onto the back page. So we're going to use that idea of Pythagorean triples to decide, and the Pythagorean theorem to decide if there's a Pythagorean triple happening on the given example. So there's a missing side length. We'll just call that x for right now. And then I'm going to decide which one side's going to be my c. Since 15 is across from the right angle, I'm going to call that my hypotenuse, c. And then we have x squared plus 12 squared equals 15 squared. So we're going to solve for this x and then decide if x is a whole number, it is a Pythagorean triple. If it's not a whole number, then it's not a Pythagorean triple. So we'll solve it just like we did on the front. So when I square 12 and 15, I'll subtract 144, so we get our x squareds by themselves. We're left with 81, and when I take the square root to get rid of that squared, I get x equals 9. So since this is a whole number, 15 is a whole number, 12 is a whole number, this is a Pythagorean triple. Taking a look at the next example, so this time our x, or our missing side length, is our hypotenuse. So I'm going to go ahead and solve and decide if we get a whole number, it will be a Pythagorean triple. If not, then it's not a Pythagorean triple. So when I plug these all in, it doesn't matter which one's my a, which one's my b. So we'll go 15 squared plus 9 squared equals x squared, we'll call it. 15 squared is 225. 9 times 9 is 81. And when we combine these two, we get 3. Oops. My apologies. get 306. And when we take the square root of 306, we end up getting about 17.49. It goes on forever. It's a rational. So since we get that decimal or an irrational answer, this is not a Pythagorean triple. The last part, so part of our learning target was talking about just using the Pythagorean theorem. The second part of our learning target today is using the converse. So the converse of the Pythagorean theorem gives you a way to tell if a triangle is a right triangle when you note the sides. So this is something that I use a lot in the summer when I'm building houses and stuff like that. I can use both Pythagorean triples or the Pythagorean theorem to decide if two walls, like obviously in a corner you would want it to be 90 degrees in your house because you wouldn't want it to be, or even like your ceiling, you would want it to be 90 degrees. So it's you don't want to have a brand new house that's slanted. So this is something that I've applied a lot in my career outside of math class, so it's kind of a good thing to know. So the converse of the Pythagorean theorem basically says that if you can plug the three numbers into the Pythagorean theorem and it's equal, then it's a right triangle. So if you can plug it into Pythagorean theorem and it is equal, then it is a right triangle. So one thing to add with this converse of the Pythagorean theorem is that if we don't have it equal, we can also classify. So we can classify the triangle based on its angle. So since we are just classifying if it's a right triangle, that means it's got to be equal. If we notice that our C is larger, when we do our a squared plus b squared equals c squared, if we notice that we get a larger answer for our C, then that means it's going to be obtuse. So we can kind of see in this picture here how if C is larger, it creates a larger angle across from it. We talked earlier this year about the relationship of the sides to the angles. So this is kind of going along with those ideas and concepts that we spent before. And the opposite so if C is larger, then we have it obtuse. If C is smaller, so this is saying if C is less than a squared plus b squared, then we have an acute. So we can kind of see this relationship of the smaller side across from this angle. So the way that we decide, like in this case, it would be hard to decide which side is C, but the way that we're going to decide what is C is which is the biggest number. Now another thing that I want to add is that sometimes we can have pairs of numbers. So as you can see in the next few examples, that I'm going to give you three numbers. A triangle has three sides, so we have three measures. We're going to decide if, based on the side lengths, if it's a triangle first. So I'm just going to switch over really quick and show you guys a little Desmos. So if I notice, so if we look at these three pairs of numbers, I have an A, B, and a C, or A, B, B, C. If I change these, we can kind of see the lengths change a little bit. So if this triangle sum theorem, or this triangle length, if the lengths of two sides are smaller together, if I add them together to be smaller than the biggest side, So the two smaller sides. Notice that if I were to try to connect these two sides, this B, they would combine, because when I add 9 plus 10, it doesn't equal 22, it's smaller. But if I do have a number that's smaller than 9 plus 10, I can connect these to make a triangle. So the first thing we want to do is decide if the biggest side is smaller than the sum or the adding of the two smaller sides. So we always have three numbers. So we're going to look at those three numbers and which one is the biggest. So we're going to decide that 13 is the largest because 8 and 11 are smaller than those. So this is our biggest number. Right off the bat, I know that that's going to be my C if I have to do the Pythagorean theorem. When I add 8 and 11, 8 plus 11 is 19. 19 is larger than 13. So that means, yep, it can be a triangle. Yep, it's a triangle. So then I can start using this converse. So I'm going to call 8 my A, 11 my B, and we already decided that 13 is a C. So I'm going to use the Pythagorean theorem. I'm going to plug those in, and if I get the two sides are exactly equal, then it is a right triangle. If for some reason the hypotenuse is larger, or if our C is larger than the other side, then it is obtuse. If it's smaller, then it's going to be acute. So if I go ahead and simplify these, so 8 times 8 is 64, 11 times 11 is 121, 13 times 13 is 169. Combine these two. When I add, we get 185. 185 does not equal 169. So therefore, this is not a right triangle. And so this was my C, since the C ends up giving us this 169, and 169 is smaller than 185, we find that this is an acute. This is an acute triangle. So we're basing our judgment on that hypotenuse, that C. So let's take a look at the next example. Oh no, decimals. Excuse me. So the first thing that I want to do, decide if it's going to be a triangle or not. So I'm going to decide which number is the biggest. I won't always have them in order, but this one, they happen to be in order here. So this is going to be my C because it's the biggest. So I'm going to go ahead and add 5.8 and 9.3. 5.8 plus 9.3. Now if that number is bigger than 15.6, then we can go ahead and use our Pythagorean theorem to decide what type of triangle it is. If not, then it's not a triangle and we're done. So when I add those two numbers together, I get 15.1. And 15.1 is smaller than 15.6. So this is not a triangle. So if it's not a triangle, that means we can't classify it as being a right triangle, acute triangle, or obtuse triangle. So that would be our answer. We're going to just, if it's not a triangle, we'll just leave it alone. The last one, so this is our largest number, 16. So let's first of all see if it's going to be a triangle. This step, I understand that you can probably do in your head, but if you could at least show this work right here, it will only take you like 2 seconds. So 19 is larger than 16, so yep, it is a triangle. So we're going to go ahead and plug these into our Pythagorean theorem. I'm going to call 7 my A, 12 my B, and we already decided 16 is our C, so we have 7 squared plus 12 squared equals 16 squared. When I combine 49 and 144, I get 193, and 193 is smaller than this 256, so our c squared is larger, so it is obtuse. So again, refer back to these examples for your homework, because I kind of broke the sections on the homework into relate to each of these examples. So and please just make sure that you're showing all your work, and thank you for